Every single second, we generate a constant stream of raw information. We track daily step counts, log temperatures, and snap millions of photos. Imagine being the captain of a cricket team. After a match, someone hands you a list recording every single ball bowled, every run scored, and every catch dropped. At that stage, that list is just a series of raw events. You cannot easily see who the best bowler was, or which specific overs yielded the most runs for the opposing team. Having a massive list of facts is not the same as having actionable knowledge. Without organization, all of those data points are just noise. Data only becomes a useful tool when we deliberately collect and organize it. This transition from a chaotic list to a structured format is what allows us to actually learn from what happened during the match. This graphic shows the 4 primary methods we use to capture real-world data: direct observation, asking questions through surveys, recording physical measurements, and passive digital tracking. The moment that information is collected, it splits into 2 categories. That division dictates exactly how computers can process it. On the right, unstructured data includes complex formats like videos, audio recordings, and social media posts lacking a fixed format. By contrast, structured data is highly organized, fitting neatly into searchable rows and columns, like a table of student marks. Because computers cannot easily compute messy, unstructured files, we must find ways to translate and organize that information into structured formats before using it. To make digital data useful, it must be stored in specific file formats, affecting how quickly computers read and share it. For example, a database stores data in structured tables, made up of individual rows and columns containing specific fields. There are other formats for different needs: CSV text files for raw values, spreadsheets for manual sorting and charts, and XML files to organize data for the internet. Even in the right format, data isn't necessarily ready to use. We must first go through data preparation to ensure all information is accurate. This involves cleaning the data, removing duplicate entries, filling in any missing values, and sorting the items logically. Clean, organized data is a requirement. Without it, no visual chart or automated system can provide an accurate result. Once the data is cleaned and formatted, we can begin identifying broader patterns. This often starts by translating long tables of numbers into visuals that the human brain can process more easily. As this diagram shows, line graphs use an upward arrow to reveal changes over time. Other tools, like pie charts, are used to show how different parts contribute to a whole. These same structured grids are also the foundation for artificial intelligence. In this context, they are called data sets, and they act as the primary information source machines use to learn. To teach a model to recognize patterns, data scientists divide these sets into 3 parts: one to train the model, one to validate its accuracy, and one to perform a final test. This illustration shows how AI uses this data for processes like clustering. On the left, it groups weather data into hot, cold, or rainy days. On the right, it automatically sorts photos into folders based on the person or location. The next time you see a data visualization or a predictive AI, remember that the result is not magic. It relies on the human-driven process of turning a chaotic world into structured data.